Okay, we have learned before that a function is specified by its way of operating on its input. That's the first characteristic of a function, how it operates on its input. That's what characterizes a function. And the second thing is its domain. We can have two functions that may operate in the same way but with different domains. For example, if I give you this function f of x is equal to root x squared and another function which is g of x is equal to x, what is the difference between these two functions? What would you expect the difference between these two functions? If you made this simplification, root x all squared, what is root x squared? It is x. So can I say that f of x is equal to g of x or not? Is that a true or false statement? This is false. Why is it false? Why do you think f of x is not equal to g of x? Although they both operate on the same way on the input. They both give x. At the end, they both give x. But what is the difference between these two functions? The difference is the domain of each of these functions. What is the domain of f of x? Here there is a restriction I have here, which is x must be greater than or equal to 0. So when I make this simplification, we have learned in the lesson of the domain that making simplifications changes the domain. Making simplifications changes the domain. That's why that if I asked for a domain of some function, I don't make any simplifications. I don't make any simplifications before finding the domain. Maybe after finding the domain, I may do some simplifications, but after I have known the domain of the function. Okay? So for example, this function, its domain that x must be greater than or equal to 0. So when I make this simplification, when I say that root x squared is equal to x, that is the way that the function operates on its input, I must say that, remember that x here must be greater than or equal to 0. And then when I make a graph of this function and this function, what is the difference between the graphs of these two functions? The graph of this function is x like this. What about the graph of this function? It will be x, yes, but only for x greater than or equal to 0. So it will be like this. Okay? So that's the difference between two functions. Maybe I have two functions that they operate on the same way on its input, but they have different domains, so they are different functions. So in this way they are different functions. Okay? And we have learned how to find the domain for different problems. Also I've learned the absolute value function, and we have solved some problems of finding the domain and solving inequalities, including absolute value function. If you don't remember any of these, just revise the previous lectures 1 and lecture 2. Okay, in this lesson we'll study something called transformations of functions. These are the meanings of some geometrical transformations. We will make some geometrical transformations. We will know how to express these geometrical transformations analytically. So let's see the first transformation. There is something called shift. We may do a shift in a function. Changing somehow in a function is called a transformation. For example, if I have this function, if I shifted like this, I made it starting like this, that is called a horizontal shift. That is called horizontal shift. If I took this function and I made it like this, what do you expect that will be? that is called a vertical shift. That is called a vertical shift. Now we need to express these two geometrical transformations but analytically. We need to make a connection between the expression of these geometrical. I may do these transformations geometrically. I tell you, make a transformation by 2 steps in the right side. Okay, you may do this transformation, but how to express that analytically? How would that change the expression of the function? That is what we will study in this lesson. Okay, now the first rule for shift, we will study first horizontal shift. Horizontal shift. The rule says that if I have a function, some function like this, and which is called f of x, then if I remove every x with x plus some number, it makes a shift in the opposite side of that number with number of steps equal to, or with a distance which is just equal to a. What do I mean by that? That will be, for example, that will be like this. If a is greater than 0, is a is positive, it will be in that direction. So, for example, if I had this function which is f of x equal to x squared, this is called x squared, and we have learned these basic functions. We have learned what is this function called? X power n. We have given it a name. What is the name of this function? X power n. You remember it was called no, not a polynomial. We need a more basic definition of this function. I'm not telling you x squared plus 3x. We have just built a polynomial from this function, from these functions. We called a polynomial the linear combination of power functions. These are called power functions. If we say x power n, they are called power functions. Okay? Now, this is a function which is easy to draw, which is easy to graph, which is x squared. Now, if I need to make a graph of x plus 2 all squared, what did I make analytically in this step? I have just replaced every x with x plus 2. Okay? What does that mean graphically? It means if you just remove every x, or if you replace every x with x plus 2, it means that you would take that graph and shift it in the opposite direction. That direction is plus 2. In which direction would I shift the graph? To right or left? To left, yes. In the opposite direction of the opposite. Plus 2 in that direction. So I will just shift it in the opposite direction, which is negative 2. So that will be like this. Instead of starting at 0, it will start at negative 2. Okay? So I just shifted like this. So if I had, for example, if I needed to make a graph of this function, graph x minus 3 all power, no, we'll make it x minus 1 all power 3, starting from x cubed. Now, the starting function is x cubed. Can I make a graph of x cubed? Yes, I've learned how to graph any of the power functions that I've learned. Okay? What is the graph of x cubed? Do you remember? It is like this. That is the graph of x cubed. Now, if I need to make a graph of x minus 1, how would I make that? That is x cubed. What is the change that I need to do to be x minus 1 all cubed? What is the change in this step? I am replacing every x with x minus 1. And what does that mean graphically? It means a horizontal shift In which direction? Plus 1. Yes, plus 1 means one step or a distance 1 in the right direction. Positive means right direction. Positive means right direction, and negative means left direction. Okay? So whenever I have this function, so how would be the graph of this function? It will be shifted 1 in this direction, in the right direction, and the graph will be something like this. Okay, instead of starting at the origin or passing through the origin, it will pass through this point, which is 1 and 0. Okay, so that is called horizontal shift. That is called horizontal shift. Now I need you to make a graph of root 1 plus x starting from root x. I need you to make it now. With your pen and paper, yes. Start doing it. You would have solved it by now. Yes, correct. First, we need to remember that we have learned that root of x. What is the graph of root of x? That is one of the power functions. That is one of the power functions which has this graph. Okay, so that is root x. So what change would I do here? I will replace every x with x plus 1. And that means a shift, horizontal shift, in which direction? Negative 1, which is in the left direction, and it will be like this. Okay? Now, what is the step if I say x is replaced with x plus 1? This step is expressed mathematically by saying this is f of x plus 1. For example, if I had f of x is equal to root x, then what is f of x minus 2? What is meant by this step? It means to replace every x in this expression by x minus 2. That's what we have just stated its graphical meaning. Okay, so instead of expressing the step by replacing x to by x plus or minus some number, we may express it like this. Give a graph starting from this function f of x, graph f of x plus 2. For example, I give you some f of x, then I ask you to graph f of x plus 2. What is meant by this? It means to replace every x with x plus 2, and graphically it means making a horizontal shift with negative 2. Okay, now that is for horizontal shift. What about vertical shift? Vertical shift. For vertical shift, if we say the rule states that if I have some function y is equal to f of x, then if I need to graph y equal to f of x plus some number, you just shift the function vertically in the same direction of that a. Okay, so for example, if I had f of x is equal to x squared, which is that function, if I need to graph a function, let's make it g of x. Let's use different symbols. I'll just use different symbols. If I need to graph the function f of x plus 2, which is f of x plus 2, a new function here is z, f of x plus 2, which is x squared plus 2. Now in this case, instead of replacing every x with x plus or minus a number, I will just take the whole function and add or subtract some number. I will take the whole function and add and subtract some number. In this case, the shift will be in the same direction as that number. So that means, but vertically. Okay? So in this case, I will just take a vertical shift. That will be a vertical shift. That means that taking the function plus 2. What does that mean for me? It means a vertical shift plus 2. Now remember, in the horizontal shift, I shifted in the opposite direction of the number. But in the vertical shift, the shift is in the same direction of the number. Okay? It is in the same direction of the number. So in this case, f of x squared, it will be x squared plus 2. It will be graphed like this. It is shifted upwards. It is shifted upwards 2 steps, or for a distance of 2. Okay? If I need to graph f of x minus 1, which is x squared, I need to graph x squared minus 1. How would I graph this function? I've just seen this as x squared. I've seen it as x squared first. Then I would start with x squared. Then I take the whole function and subtract 1. It means making a vertical shift, but downwards 1 step. So that will be something like this. Okay? We should make a difference between replacing every x with x plus number or by making a shift. By making a vertical shift, or taking the whole function and adding or subtracting some number. Okay? So, for example, if I need to graph root x minus 3. Root x plus, starting from root x. Now I need you to make this graph. Now yes, correct. Now we'll start from root x. My target is to be root x minus 3, and that is the whole function but negative 3. What does that mean to me? It means to make a vertical shift with plus 3 or negative 3? Negative 3. Downwards 3 steps. So if I start here, that is the graph of root x. And the graph of root x minus 3 will be starting from negative 3. I just moved it downwards 3 steps. So that will be like this. That will be something like this. Okay? Now if I ask you this problem, sketch y equal to x minus 3 all cubed plus 4. Now this is a combination between two transformations. Starting from x cubed. Now let's start from x cubed. What transformations would I do to target this function, or to be in this formulation? Okay, we may replace every x with x minus 3. So the function will be x minus 3 all cubed. That is a step. Okay, now I'm closer to this function, but still needs one further step, which is take the whole function and make plus 4. Take the whole function and make it plus 4. That will be x minus 3 all cubed plus 4. Okay? What is the graphical meaning of each step of these? The first, it will be a horizontal shift. Plus 3 or negative 3? That will be plus 3 to the right. 3 steps to the right. Okay? What is the meaning of this transformation? If you take the whole function and add 4, take the whole function, take that function, the whole function, and add 4. What is meant by this graphically? It means a vertical shift with plus 4 or negative 4? Plus 4. That will be plus 4. Okay? So let's interpret that graphically or depict that graphically. That is x cubed. The next step is to make shift plus 3. So it will be like this. Shift plus 3, it will be like this. Another step, that will be shift, vertical shift plus 4, which means to take it upwards for 4 steps. So that will be something like this. Okay? So that's the function. So I may have various combinations between the transformation that I've learned. Okay? So we have learned two shifts, a horizontal shift and a vertical shift. Now we learn the scaling transformation. Scaling. Also for scaling we have two types of scaling, horizontal scaling and vertical scaling. Okay, for horizontal scaling. Horizontal scaling. What is horizontal scaling? It states that if you replace every x with ax, some number x times x. I need you to turn off your mobile. Please turn it off. If x is replaced with ax, what does that mean? Graphically, it depends on the value of a. It depends on the value of a. So, if I have a greater than 1, and if I have a less than 1. If you remember that in horizontal shift, the graphical transformation was in the opposite direction of a. Do you remember? In the horizontal, it was in the opposite of the number a, in the opposite direction of the number a. Also, in this case, we will have a similar situation. For horizontal scaling, if a is greater than 1, it means that the function will be squeezed. It will be compressed. Maybe you may say a is greater than 1, that it will dilate. No, it will be compressed. It is just the opposite of that number a. Okay? So it will be squeezed, compression or squeezed. Compressed or squeezed. Okay? Now if a is less than 1, it will be dilated. It will be dilated or expanded. Expanded or dilated. Okay? Both transformations are horizontal. We are talking here about horizontal scaling. So what I'm doing, whatever it is, a compression or it is an expansion, they are all horizontal. Okay? So for example, if I have this function f of x, which is x squared, okay, which is graphed like this. Now, if I replace every x with 2x, what will be the new function? It will be g of x will be, which is f2x, it will be 2x all squared. Okay? What is the graph of 2x all squared? Now, I have just noticed that x is replaced with a number times x. I will just check if that number is greater than 1 or less than 1, it is greater than 1. So we'll have a compression or expansion. We'll have a compression. So that the new function will be something like this. That is g of x, and that is in the blue it will be is f of x. Okay? And that occurs for any function, for any given graph of function. If you replace every x with ax, we'll have a compression or an expansion. Okay? So if I replace every x with x over 2, what do you expect the graph of that new function? H of x will be x over 2 all squared. It will be a horizontal compression or expansion. That will be an expansion. So it will be something like this. Okay, I have just expanded it horizontal. Okay. In a similar pattern, we will have vertical scaling. Vertical scaling. What is the statement of the rule? It states that if I have some function y is equal to f of x. Now, if the whole function is multiplied by some number a, if the whole function is multiplied by some number a, so it depends on that a. If a is greater than 1, now remember in the horizontal, in the vertical shift, it was in the same direction of a. In this case, it will be just the same meaning of a greater than 1. Okay? So if a is multiplied by the whole function, if a is multiplied by the whole function, it means that we'll make an expansion, a vertical expansion. We'll make a vertical expansion. A greater than 1, you are just expanding the function vertically. Expanding the function vertically. Okay? Now if I have a less than 1, we are making a compression vertically. Okay? We're making a compression vertically. So, for example, if I had x squared, which I know its graph like this. Now, if I multiply that x squared by 3, what do you expect the output would be? That is g of x, for example, and that is f of x. Now, I have noticed that in this transformation from x squared to 3x squared, I have just taken the function and multiplied it by the whole function and multiplied it by 3, which means a vertical scaling. Multiplying means scaling. Adding or subtracting means shift, means a shift. Okay? Now, for this case, we are making a compression or we're making a expansion. We're making an expansion because we have here 3 is greater than 1. So this is a vertical expansion. Now just take a close look here. We just expanded vertically. So that will be something like this. Okay. الإكس إيه؟ لا ما في فرق هنا. طيب خلي سؤالك ده بعدين بعد Now, some we may notice that this function is close to this one. What is the difference between this red one, which was created by a horizontal compression, that was made by a horizontal compression, but this one is made by a vertical expansion? These two transformations may be equivalent. We may have equivalent transformations, but they may give the same result at eventually. How would that be? Let's make it 4 instead of 3. Let's make it 4. That wouldn't make a difference for this function. Okay? Now 4x squared, if I need to graph 4x squared. 4x squared can be seen as in two ways. One way is to say it starting from x squared, then having that function multiplied by 4, which is a vertical expansion. Vertical expansion. Okay? Another way to see 4x squared, we can say it another way. Do you have any suggestion for saying 4x squared in another way? I may say it as 2x all squared. This is just the same function as this. Okay? So if I start by x squared, which transformation which may transform x squared to 2x all squared? It is replacing every x with 2x. And what is this meant? What did this transformation graphically mean? It means horizontal compression. Yes, in this way, in this case, it will be a horizontal compression. Both functions are the same, but I may say them by different transformations, and the result will eventually be equivalent, or will be they also be the same. So I may have different transformations, but they will eventually give the same result. So this function, I may say it as a horizontal compression, or in another way I may say it as a vertical expansion. Okay? Now, does any vertical expansion is equivalent to a horizontal compression? No. We'll just learn another function which is called sine x. We'll learn that function afterwards. We learn a function called like this. In this function, if I make a horizontal compression, it will just be like this. It will just be like this, horizontal compression. But if I make a vertical expansion, it will be something like this. So these two are different operations, a vertical compression and horizontal. But in some functions like this, and that happened for the expression of this function, I have just made it like this, or I could make it like this. I have managed to make some mathematical simplifications to be in two forms. That's why in some functions, maybe some transformations would be equivalent. Okay? Now, if I need to graph this function, if I need to graph 2 root x plus 1 minus 1, can I make a graph of this function? Yes. Starting from root x. Starting from root x. Okay, let's start from root x. What transformation would I do to make it closer to this form? Let's replace every x with x plus 1. So that gives me x plus 1. This form is just closer to the targeted form. Okay. What another transformation that which made me more closer to this, more close to this function. We would make the function, the whole function, and make it times 2. Okay, so that will be 2 root x plus 1. Still, we need another transformation to make it like this form. What transformation would I need? The whole function, but make it minus 1. So that will be 2 root x plus 1, but all negative 1. Okay? Now let's interpret each transformation graphically. That will mean x replaced by x plus 1 is horizontal shift negative 1. That will be horizontal scaling or vertical scaling. That is a vertical compression or expansion. Expansion. Yes, vertical expansion. That will be vertical shift in direction of negative 1. Yes. So these are the 3 transformations that I need to make on root x to get the graph of this function. Okay, so I'll have root x, then I will just make it horizontal shift negative 1, so it will be like this. Then I would make a vertical expansion, so it would be something like this. I just expanded it vertically. Okay, then the final result will take that function and make a vertical shift minus 1, so that will be something like this. Negative 1. I have just shifted it negative 1. Okay? Now these are 4 shifts. We have studied now 4 transformations. 2 shifts and 2 scaling transformations. Now we will study. So these are 4 basic transformations. Now we will study reflections. First, we'll have horizontal reflection. What is horizontal reflection? Horizontal reflection is making a reflection about the y-axis. How is that expressed analytically? That if that happens if I replace every x with negative x. So if I have some function f of x, if I need to graph f of minus x, I have some function f of x which is maybe like that. Okay, and I need to graph that is f of x. I need to graph f of minus x. How would I get from x to f of minus x? I just replaced every x with minus x. How would be the graph of f of minus x? It will be reflected. Assume that there is a mirror on the y-axis. So in this way, in this case, it will be something like this. So that will be f of minus x. The graph found in black is f of minus x. Okay? So for example, if I told you please graph the function f of x which is equal to root negative x. First, does that function root negative x, does it exist? Root negative x, does it exist? Yes, it normally exists. It doesn't, we don't have a problem here. Some would say, how would I say that I have a negative inside the root? Is this confirmed to be negative? No, if I told you for this function, I gave you this function, and I told you find the domain of this function. I told you find the domain of this function. What is the domain of this function? Negative x would be greater than or equal to 0. So if I multiply by negative both sides, that will be x less than or equal to 0. Which means that this function can normally exist, but in the condition that x must be less than or equal to 0. And that is logically accepted. If I have x is negative, so when I multiply it by another negative, the whole result inside the root will be positive, so I have no problem. So this is an ordinary function. We don't have a problem in this function. Maybe just the domain is just different from what I have been traditionally dealing with. Okay? So if I need to graph this function, now I need to graph this function. What I know is root x. How would I transform it to root minus x? What is the transformation that I would make in this case? It is to replace every x with negative x. Replace every x with negative x. So what does that mean in the transformation that I have studied? It means making a reflection about y-axis. So if I know the graph of root x, which is like this, how would I graph root negative x? Let's make it in black. Let's make it in black. I need to graph root negative x in this on the same axis. That will mean I will just make a reflection about the y-axis. It will be like this. So that is root negative x. That is, if I need to graph it just alone, it will be like this. Root negative x. And it's obvious that its domain is for only the negative values of x. Its domain, the allowed values of x are all negative. Okay? What about graphing this function, root 2 negative x? Starting from root x. Starting from root x. We have to pay attention in problems like this. Now I will start with root x. Okay? I will start with root x. Let's make a transformation which is replacing every x with negative x. So that will give me root negative x. Okay? Okay. That is closer to the targeted form. Okay. Let's make another transformation. I need to make it like this. What do you expect the next transformation would be? It will be a shift. Okay? It will be a shift. But what will be the shift, the needed shift? Would I say replace every x with x plus 2 or x minus 2? What is the suitable shift in this case? Is it x? I replace every x with x plus 2. Would I take it at the same sign of this number? Or would I take it x minus 2? Let's do it. Let's do it in detail. If I have this root negative x, if I try x plus 2, let's try x plus 2. Replacing every x with x plus 2. What would be the result? The result would be minus x plus 2 like this? No. I need to replace every x with x plus 2. So that will be a bracket. That will be a bracket like this. That will be a bracket like this. So in this case, the result will be root negative x negative 2. Is that is that equal to the targeted form, or that we'd like to be the form of the function? No. So this is not the suitable transformation. In this case, this is not the suitable transformation. What about trying to make it x replace every x with x negative 2? Let's try it. If I replace this x with x negative 2, it will be negative x negative 2. What will be the result? It will be negative x plus 2. Is this equal to the targeted form? Yes. So this is the more suitable transformation in this case. So I will not say x replaced with x plus 2, I will say x replaced with x minus 2. Okay? So that will give me root x, root 2 minus x, which is the targeted form. Now let's express each of these steps graphically. This is meant by a reflection about y-axis. This means a reflection about the y-axis. And this means x is replaced by x minus 2. It means horizontal shift plus 2. Horizontal shift plus 2. Okay? Let's make the graphs. Okay, I will start with root x. That is root x. Now, this will be root negative x. We have just given a graph of this function that will be something like this. Okay, let's make a horizontal shift plus 2. So I would shift it in the right direction plus 2. So that will be the graph of this function will be something like this. Okay? If this is the only way to solve this problem, no. I would have started by making the shift. How? Let's start by root x. If I made a shift, x replaced with x plus 2. So that will give me root x plus 2. Okay? That will give me root x plus 2. Then I would replace every x with negative x. What is the result in this case? It will be, I will just replace that x with a negative x. So that will be negative x plus 2. Is this the same form as the given problem? Yes. So this is another method, and I prefer this method. Why? If I look in some problem, now I may look in some problem like this, and I just notice that the x has a negative sign. In this case, I will just try to make a graph of 2, and I make the coefficient of x to be positive like this. Why? Because if I successfully graph this function, to get that function from this one, it will be just easy. I will just replace every x with negative x. But it's always better to have a positive coefficient for the x. So whenever you gave me that problem, I just have noticed that the coefficient of x is negative. Let's graph the same function but with a positive coefficient of x. And if I have graphed this function, I will just make that step to make it the needed form. Okay? So in this case, that is root x. Then root x plus 2, that will be a function. That means a horizontal shift, negative 2. So that will be like this. Horizontal shift, negative 2. Then I will make a horizontal reflection, which is like this. So the graph in black is just this function. As you see, it is just identical to that graph found by the other method. Okay? So we have made different transformations, but eventually they give the same result. Eventually they give the same result. Okay? Now, as we have learned a horizontal shift, there would be a horizontal reflection. We have just studied the horizontal reflection, a reflection about the y-axis. There will also be a vertical reflection. Vertical reflection. What is vertical reflection? If I have some function, if I take that function and multiply it by a negative. As you would see a similar pattern, that the vertical transformations are all looking for making the transformation for the function as a whole. Vertical transformations, you may have noticed that vertical transformations make the transformations for the function as a whole. Sometimes I would just add or subtract a number. Sometimes I would multiply the function by a whole number. Sometimes in this case, just like this case, I would just multiply the whole function by a negative. But horizontal transformations were all made on x only, replacing x with x plus or negative number, x multiplied by some number. X is replaced with negative x. All the horizontal transformations were on x, replacing x with some other form of x. But vertical transformations are made for the function as a whole. So in this case, if I need to graph this function, what is a vertical reflection? It means a reflection about the x-axis. Reflection about the x-axis. So for example, if I need to graph negative x squared, starting from x squared. Now this is x squared. What is the transformation that you have made from x squared to negative x squared? You have multiplied the whole function by a negative. You multiplied the whole function by a negative. So in this case, what would be the graph of the function? It will be like this. Okay? What about if, for example, if I need to graph negative root x? Yes, that will be, I know that root x is like this. So negative root x will just be, make a mirror on the x-axis. We're taking the whole function, multiplying by the negative, so that will be like this. This is negative root x. Okay? And this is positive root x. If I need to graph 3 minus root x plus 1, starting from root x, 3 minus root x plus 1. Okay, let's start from root x. I would make a x, replace it with x plus 1. Okay, that will give me root x plus 1. Another transformation is, I would take the whole function and multiply it by a negative. So that will be negative root x plus 2. Then I would take that whole function and add 3, not a negative 3, yes, add 3. That is this function is just this. I will just add 3 for it. So that will give me 3 plus or 3 minus, which is the required function. Okay, now let's interpret each step graphically. That is horizontal shift -1. That is vertical reflection. That is vertical shift +3. So let's make these transformations. I have here root x, make horizontal shift -1, so that will be this. The graph of this function will be like this. Now for this one, the graph of this vertical shift, make a vertical shift, so it will be like this. Vertical shift is made like this. Why it is called a vertical shift? Because it is the direction of the reflection is in this way. It is just normal to the mirror. Normal to the mirror. Okay, now that is negative root x plus 2. Now then I make a vertical shift +1. So the graph of this function will be, yes, I will just start upwards, yes, like this. It will be like this. So that is the graph of this function. Okay? Now we still have two other reflections. One is called absolute reflection. Horizontal absolute. No, this is absolute reflection. If I have some function f of x and I make an absolute for the whole function, I make absolute for the whole function. Okay? In this case, it will give me absolute f of x. How to make a graph of this function? Let's give a graph of f of x like this. That is f of x. Okay? I need to graph absolute f of x, that function, or to make that transformation. What do you expect the result of absolute of the function? Would a result of this function, absolute f of x, would it give me a negative value? It will never give me a negative value. It will never give a negative value as an output. So what about these values for f of x? What would you expect this transformation would do for it? It would just make it as positive. So the new function would take the positive values, the positive results, would just make it as it is positive. We'll just leave it as it is positive with no change. Then for any negative results for the function, it will take it and make it all positive. It would just make a reflection for these values only. For the negative, it would make reflection for the negative values only. Okay? Then it will continue like this. Then it will be like this. Okay? So this is the graph in black is absolute f of x. The graph in blue is f of x itself. Okay? So this is absolute reflection. It just occurs when I put the whole function inside an absolute. If I put the whole function inside absolute. The last reflection is x absolute. It happens when I replace every x with absolute x. If I replace every x with absolute x, or it is called f of absolute x. In the previous transformation, the whole function was inside the absolute. No, in this case, I will just replace every x with absolute x. So what would that transformation mean graphically? Now pay attention in this transformation. If I have a function like this, that is f of x. Okay? Now I need to graph f of absolute x. How would that graph be? The first step is to remove the negative part of the function. So I will just remove this part. Okay? The second step is to make a reflection about the y-axis. The second step is to make a reflection about the y-axis. So what would be the result of this function? The result will be something like this. Okay? So it means two steps. The first step is to remove the negative part of the given function. And this step is a forgettable step. Many students forget this step to remove, and then they get confused. How do they deal with the situation? In this case, they don't know. You just get confused. So the first step is to remove or to erase the negative part of the function on the negative side, on the negative x side of the function. Then we make, for the positive side, we just take it as it is, but a reflection about the y-axis. Okay? Starting from x squared, give a graph of absolute x minus 2 all squared minus 3. How would I make a graph of this function? Now, I have just, when I notice an absolute in the function, I just make first the problem without the absolute. Okay, for any given problem, I just make, if I see an absolute given in the function, I just make the problem without the absolute. Then the step of putting an absolute, either by the whole function, putting the whole function absolute, or replacing every x with absolute x, each of these steps are easy. Okay, so but we just need first to give or to have a graph of the main function without absolutes. To have a graph of the function without absolutes. Whenever I have that function, any other step, I will just take it all, put it all in the absolute. That is just a reflection, which is easy to do. Okay? So now he's giving me this problem to give a graph of it. What would be my focus? I just need to graph x minus 2 all squared minus 3. That is my focus on this step. How would I graph this? Yes, we have learned to graph this function. Starting from x squared, I will just make x, replace every x with x negative 2, which is horizontal shift plus 2. Then that will be x minus 2 all squared. Okay, now then I will take the whole function and negative 3. The whole function, negative 3. That is vertical shift, negative 3. Yes, so that will be x minus 2 all squared, negative 3. Now I have just arrived to that form. The last step is just easy, just to put this function, the whole function, inside the absolute. To put the whole function inside the absolute, so that will be absolute x minus 2 all squared minus 3 like this. Okay, and that is absolute reflection. That is absolute reflection. Okay, now let's make these steps. That is x squared. I will just horizontal shift plus 2, so that will be like this. Then I will just shift it vertically to downwards 3 steps, so that will be something like this. Then I will make absolute reflection. What is absolute reflection? Any result, any negative result, make it as positive. Yes. So the needed result is just this red function. That is that red function. What if instead, what if for this function, what if instead of finding absolute x minus 2 whole squared minus 3, instead of this, I just needed to graph absolute x minus 2 whole squared minus 3. Yes, from this case, I will just, starting from this one to this one, by which transformation? Yes, replace every x with x absolute, or absolute x. That means to remove the negative part of the function, then make a horizontal, then make a reflection about the y-axis. So that will be like this. So that function is graphed like this. Okay, have you grasped the idea? You may find some other exercises. If I've grasped the ideas that we have that I have taught you today, you may manage to solve the problems. You will find extra problems in the PDF of the lecture. We'll start a new lesson, which is trigonometric functions. Trigonometric functions. Maybe you have countered these functions, which they are called sine theta and cosine theta and tan theta. Any of you that does know these functions? They have meted or now, these three functions are main functions in engineering that we need a lot in our study. Along our study journey in the faculty, we'll just need these main functions, which are called trigonometric functions. They are called trigonometric functions because they come from a triangle. If I have a triangle with angle theta, if I have some triangle with angle theta with these okay, if I have this triangle, now each of these functions define a ratio of حد يعرف الأضلاع بتاعت المثلث اسمها ايه بالإنجليزي؟ ضلع. Side, yes. Each side of this triangle, if I need the ratios of the sides of this triangle, each ratio define one function of these. Okay, what is cosine theta? Cosine theta, if you have this as the theta, if you find the ratio of A divided by C, which is called the adjacent side, adjacent divided by the hypotenuse, which is C. Okay, that is called cosine theta. That defines the cosine of the angle. What is sine theta? Sine theta is the opposite, which is, no, this is C. This is C. The hypotenuse is C. Okay? Adjacent divided by the ratio between the adjacent and the hypotenuse. What is sine? It is the opposite, which is B, the opposite side, which is B, divided by the hypotenuse, like this. Okay? So this is the opposite divided by the hypotenuse. What about tan theta? Tan theta is just the opposite divided by the adjacent. The opposite divided by the adjacent. So that will be B divided by A. Okay? Opposite divided by adjacent. These are two main ratios. We also define the reciprocals of these three main functions. The reciprocals of these functions, the reciprocal of cosine theta is called sec theta. Sec theta is just C divided by A. It is just C divided by A. It is just the reciprocal of, or it is 1 over cosine theta. Sine theta, its reciprocal is cosec theta. It may be written as cotec theta, or we may write it as cosec theta, like this. Okay? Which is 1 over sine theta. Also we have tan theta. Its reciprocal is called cotan theta. It is called cotan theta, which is, now if you notice cotan theta, we can express tan theta by cosine theta and sine theta. If you notice, if I take sine theta and divide it by cosine theta, what is the result in this case? It will be B over C over A over C, which is exactly B over A. Okay? So another definition of tan theta is sine over cosine. The definition of tan theta is sine over cosine. So what is cotan theta, which is the reciprocal of tan theta? It is just cosine theta or divided by sine theta, or the adjacent divided by the opposite. Okay? So these are main 6 trigonometric functions. 6 trigonometric functions. Now, we have another terminology for trigonometric functions, which is called, they sometimes are called circular functions. Circular functions. Why do we have that other name, circular functions? Because we may define these two main functions, which is cosine theta and sine theta, by making use of the unit circle. What is meant by this? Now let's graph a unit circle. What is a unit circle? A unit circle is a circle with a radius 1 and centered at the origin. Now, for this circle, we have this point is 1 and 0. This point is 0 and 1. This point is negative 1 and 0. And this point is 0 and negative 1. Okay? Now, imagine that there is a point like this. Now, just connected with the origin, then make projections like this, or just look at this, make a projection on the x-axis like this. In this case, we will have an angle theta and a right triangle like this, and a right triangle like this. Just to note that all these definitions are based on a right triangle, not any triangle. Okay? These definitions are made based on a right triangle, not any triangle. Okay? Okay, now let's return to this. Now, in this case, I have a triangle. What is this length? It is just, this length is just If this point is x and y, this length is just x. This length is just x. What about this length? This length is just y. This length is just y. So now I have a triangle. One side has a length of x, another side has a length, a right triangle, one side has the length of x, another side has the length of y, and for the hypotenuse is just equal to 1. So I have this triangle, x, y, and 1. Now let's find cosine theta of this, the cosine of this angle theta. What is the cosine in this case? It will just be x over 1. X over 1. What about the sine of this angle? It will just be y over 1. So that's why x is just cosine theta and y is just sine theta. So another definition of of cosine theta and sine theta, they are the coordinates of a point moving on a unit circle. They are the coordinates. These are the coordinates. The x coordinate just gives me the cosine of that angle, theta. And the y coordinate gives me the sine of that theta. Okay? Now let's make a graph of cosine theta and sine theta. Let's make a graph of cosine theta and sine theta. I'll just erase that. That's a theta. Now for an angle theta equal to 0. Where is the angle equal to 0? That is the angle equal to 0. So that is the point which represents the angle equal to 0. This point. Now for this point we have this point, the coordinate of this point is 1 and 0. 1 is just cosine theta and the 0 is this cosine theta. So I can say that cosine 0 is equal to 1. It is obvious here, cosine 0 is equal to 1. 0 is that angle. What is the coordinate of this point? It is 1 and 0. So 1 is just the cosine of this angle and 0 is just the sine of this angle. So if I have a graph of cosine theta and a graph of sine theta, so at the first point, which is 0 at the origin, cosine 0 is just equal to 1. But sine 0 is just equal to 0 like this. So this is the first point. This is the first point. This is the first point in cosine theta, and this is the first point in sine theta. What about this point? When I just move like this to get to this point. This point has an angle which is equal to pi over 2 or 90 degrees. 90 degrees is just, we just use radian, we just use the angle in radians. Okay, the standard in faculty for measuring an angle is in radians, not in degrees. So we'll just say, when I say 90 degrees, I just state it as pi over 2. I just state it as pi over 2. Now for this angle, which is pi over 2, the point is 0 and 1. What is the cosine? What do we expect? What is the cosine of pi over 2? It is just that 0. We have just known that cosine of the angle, the coordinates of the point moving on the unit circle are just the cosine and the sine. Okay? So at the angle pi over 2, that 0 is just the cosine of the angle which is pi over 2. So at pi over 2, the cosine is equal to 0. At pi over 2, the sine is equal to, it is obvious from the second coordinate, the y coordinate, it will be 1. So that is the sine of the angle which is pi over 2. If I continue in a similar pattern, now for this point which is negative 1 and 0, so that will be, the cosine will be negative 1 and the sine will be 0. Then when I continue to get to this point, the cosine will be 0, then the sine will be negative 1, and so on. That will be 0 and that will be 1. If I connect these, I will find that the graph of cosine theta is just looks like this, and the graph of sine theta is just looks like this. Okay, now what if I have just make a whole loop like this? What if I continue? I will just repeat myself. So that's why cosine theta and sine theta are called to be periodic functions. They just repeat themselves because they are just the coordinates of a point moving on a circle, and a circle repeats itself, just continues to repeat itself. So these functions are called periodic functions. These are periodic functions. What is the period? By which angle do I repeat itself each time? If I made a complete loop is defined by an angle which is 360 degrees, or which is called in radius to be 2 pi. So the period is 2 pi. The period of these two functions is 2 pi. Now what about the domain of each of these? The domain of cosine theta and sine theta. We have learned that what is the domain? The domain is looking at the x-axis to see whether there is a graph or not. Do I have a graph on the x-axis? Yes. So the domain in this case is just the whole R, the whole real numbers R. What about the range? How to know the range? Just by looking at the y-axis. Which values do I have a graph on the y-axis? The range is from -1 to 1. Okay, the graph is bounded by -1 and 1. The graph of sine theta and cosine theta both are bounded by from -1 to 1. Okay, another property. Do you remember we have just learned before an even function and an odd function? The even function is a function that is symmetric about the y-axis. And the odd function is a function that is symmetric about the origin. So what about cosine theta? Is it even or odd function? Yes, it is an even function. Why? It is obvious that it is symmetric about y-axis. What about sine theta? Sine theta is an odd function. Why? Because it is symmetric, obviously symmetric about the origin. So that's why cosine negative theta is just equal to cosine theta. We have just learned that an even function just removes the inside negative. And sine negative theta is just equal to, it's just taken out to be negative sine theta. And that is just a statement of that property. F of negative x is just negative f of x. And because sine is an odd function, it takes the negative out of it. But the cosine, how does it deal with the negative sign inside it? It just vanishes the negative sign. Okay, I'll just give a statement of some trigonometric relations that we'll need to know and we'll use afterwards. Trigonometric relations. A first relation is cosine squared x. I will just take the variable as x because we have a habit of taking the input as x, so we'll just say x instead of theta in this case. Okay, I will just say cosine squared x plus sine squared x is equal to 1. That is the first main rule. Where does it come from? It just comes from that triangle. The cosine that side squared plus that side squared is just equal to 1 squared. That is just an expression of that triangle. Cosine squared plus sine squared is equal to 1. If I take this and divided by cosine squared, if I did take that statement and divide it by cosine squared, I will just get an expression 1 plus sine squared over cosine squared, which will just give me tan squared. So 1 plus tan squared is just equal to 1. Just equal to 1 over cosine squared. It just gives me sec squared. So 1 plus tan squared is equal to sec squared. These rules must be memorized. These are basics. Another rule, if I take this basic rule and divide it, instead of divided by cosine squared, I divide it by sine squared x. It will just give me another rule, which is 1 plus cotan squared x equal to cosec squared x. So I have cosine squared plus sine squared is equal to 1. 1 plus tan squared is equal to sec squared. 1 plus cotan squared is equal to cotan squared. I will just write double angle relations and we continue in the next lecture. Sine 2x is equal to 2 sine x cosine x. Cosine 2x is just equal to cosine squared minus sine squared. Another expression is cosine 1 minus 2 sine squared. Another expression is 2 cosine squared minus 1. Why? Because we have sine squared is equal to 1 minus cosine squared, and cosine squared is equal to 1 minus sine squared. These two relations come from the main rule, which is cosine squared plus sine squared equals to 1. So if I replace that cosine squared with 1 minus sine squared, I will just get that expression. If I remove or replace the sine squared with cosine squared by this rule, I will just get that other expression. Then we have also the rule for tan double the angle, which will be 2 tan x over 1 minus tan squared x. Okay? We'll just another important rules is how to deal with cosine of addition or subtraction of two angles, A plus B, sine A plus B, and tan A plus B. Okay, we have three rules which are important for us. Cosine A plus B is said to be cosine, and a different sign, which is negative, then it will be sine. Okay, so it is memorized cosine A plus B is equal to cosine, sine, with an opposite sign between them. What about sine A plus B? For sine A plus B, we have sine A cosine B. Then I just swap them to be cosine A sine B. For the rule of the sine, we'll just make it as the same sign. In between, we have the same sign. For the tan, we have tan A plus tan B. over 1 minus tan A tan B. Okay? First, you notice that we have complicated rules for cosine A plus B or sine A plus B. So no one must do this. Cosine A plus B, some students say that it is cosine A plus cosine B. No, this is completely wrong. Okay? We just don't use it as a linear operation or as numbers. Okay? Now, if I have a negative sign in between them, negative, so that will be opposite sign. If I have this as negative, that will be the same sign. If this is negative, in the numerator up we will have the same sign, and in the denominator we have an opposite sign. These two rules are important, especially if we need, for example, make a simplification like this. We need to find cosine x plus pi. If I need to find cosine x plus pi, let's make the simplification. That will be cosine x cosine pi minus sine x sine pi. Now I have no calculator in the exam, so I need to know what is cosine pi and sine pi. How? I have just learned by the unit circle. Pi, an angle pi is just this angle. I have this point. That is the angle pi. That is the angle pi. At this point we have minus 0, minus 1 and 0. That is just the cosine of pi, and that is just the sine of pi. Okay, so in this case that will be negative 1 and that will be 0. That will be negative 1 and that will be 0. So the result will just be minus cosine x. So I just made a simplification in this case. I just made a simplification in this case. What if I ask you, what if even or odd? Cosine x plus pi. Is cosine x plus pi even or odd function? If you remember, we have just learned that a function, if I have a function of even, what is the result of a function of even? Do you remember? If I have the inside function to be even, what will be f of even? It will be even. Whatever was f. Whatever was f. What if I have f of an odd function? If the inside function is odd, it will be as f, as the outer function. So if I have this as an odd function, it will be just as the cosine, and I know that the cosine is just even. If the insider function is even, I will have the result to be all even, whatever was the outsider function. Now let's check what is this insider function. What is the kind of this function? That is odd. X is odd. We have learned that x is odd. What about pi? Is it odd or even, or neither even or odd? It is even. A constant is considered to be even. So what is odd plus even? It is general. So this function is just general. Now, do we have a result for f of general? Would it be general? No, we don't have. In this case, f of general is not considered to be general. We don't have a rule for this case. So how would I deal with this case when I have the insider function to be general? How would I deal with it? I just deal with it by either simplifications, either by a simplification to do, or by using the main rule, which is f of minus x, and check if it is f minus f of x or f of x. In this case, what is more suitable for me? To make a simplification or to just make the f of x f of minus x? To make a simplification, I've just learned a simplification like this. So this function is just equal to negative cosine x. We have just made the simplification in the previous problem. So that function is just equal to negative cosine x. What is negative cosine x? Cosine x is even or odd or neither. It is an even function. If I multiply it by negative, would it change? No. Multiplying by a number, even if it is negative or positive, doesn't matter. multiplying by a number doesn't change the kind of the function. Multiplying by a number doesn't change the kind of the function. So in this case, that will be, by simplification, we have just deduced that it is an even function. That function is just an even function. Okay? So that's the end of the lecture.